Hello, this is my calculator that I built maybe a year or two ago. Choose one number from each module, select plussing or multiplying over there. Max output is 99, I couldn't be bothered coding all that in, it's higher than that. 15 is the highest number that can be multiplied. I indicated it by this symbol, that brick, and no number selected is 0, which currently is sort of thing. Yeah, just flicking the switch, it works with binary, so in theory there's ways of getting above 64 with using binary combinations, but you can just that's not really a purpose, but I've done it and played around with things like that before. This changes between the multiplying and the plussing thing, and it basically works off the logic of this isn't really timed based, even though there is some that are flicked back once that was just an accident, but it doesn't matter. And it basically, when there's a redstone line, it will activate it, but if there's a repeater, it won't, which you'll notice if I can get my camera in here, you can see that every second one in here will be due to the fact of how binary works. But then every two of them, then three, then five, I don't really remember, but it works pretty much right 100% of the time. Then the back is a little bit different because the sheer distances you can't get, so I had to fix that by using this weird mechanism to hopefully avoid it. Then you've got this top part, which is because every single one across this would power it. I converted what was this last line to this, I believe, which just uses inverting, just similar technique that's this part. This part's the new thing that you'd get from going up one, considering this. The 2 there, and then that goes up 1. And that actually goes up 1. Then that's why there should be a situation where those two connect. Yes, absolutely. And then you've got the system. Yeah, that's the input. Then most of this is just converting it to usability. This system, which it separates into the multiplying and plussing, which is not really needed as is needed, but it's very inefficiently done here. But since I believe this line is the multiplier lines that go through here, the 4 that you can see here, you're just using a system that inverts the signals, which is, that is constant signal, which is then sent all the way through here. And then use that. I believe underneath here somewhere there is a redstone torch, which when you flick to multiplier which is activated, that will turn off. Oh no, here it is. Found it. Which this signal goes through here, which is then and then this connects to the underside, which deactivates these rails here with just using pistons dropping down, which turn off the system. Even though this signal will come in as it should be, which you can tell that it turns off the signal because I'm currently got 0 selected, so it doesn't really, none of these are extended, so that doesn't really activate the tubing. The plus is just basically because of how binary works, it's sort of designed in a way that the two signals, after dealing with the running of it and everything, the two signals come in. The first one, this is at least, I'll probably go to the second one because the first one doesn't have the overflow, which is you get from binary calculations, which work very similar to normal calculations. So it comes in and then you see the combination. So you got, if both of these are powered and the overflow from the previous one, this one would activate. One, if it's that one, if it's just the two, if it's that one, if it's the other one, you can see that there's a redstone line that goes in there. Don't know why I did it that way when I could have shifted it. Oh, that's probably why, redstone limitations. So you can see that this one is that plus the overflow. You can tell that that is the overflow plus this one. This one is the overflow plus that one, and this is just a generic, the two of them. So you got one. If three are fired, you need an overflow as well as a feedback, which actually does turn on the system. If you just walk through what binary calculations are, you should be able to figure that out. IS, which is this. Yes, which is this. Since, yes, at the moment it is currently turned off. Yes, so that would turn, if this thing is fired, if one of these are fired, that would turn off a torch, would turn that one off. But if two are in, it will try to turn that off again using this system, and then that will turn, and if three are fired, it will activate that, which will then turn that off, meaning that does allow it to be fired because this is off, that's been powered, and allows for the signal to go through, which is combined with the multiplier up the top, which works on a very similar system to the addition, because at the end of multiplication you needed to addition and just pretty much duplicate it across all the way up. Those two lines are just from the input because the multiplier didn't need the last two, and it was just easier to send them around the back. And that's the coder, which is literally just hard coding every possible combination up to 99 using tricks with binary. It just uses pistons up if it wants to be 0 at that point. If it wants the piston itself is 1 up, so that when the extension it turns off, sort of counting for every possible combination. This back part's the way it is just for the sheer reason of the last one's sort of the same constantly, as in if the back one's powered you don't want it, sort of thing. You don't want the system to be on. I don't really know why I have this. Those are from, I think, just how the redstone works. Most of this is just hard coding it, figuring out for yourself. No real trick to that. And then just running it through the system in such a way that you produce the outputs, like the 1 lines all come up here, and then 10s all come out here, so separate. This system is done very inefficiently because of how I coded it. I was still learning how to run redstone to power it properly. upply, so it's like sometimes you see systems going back to 1, which you'll see like, I think that this is 8, if I'm correct. Yes, since 8 has the same full column as 1, I sent it back to here, which to minimize error, which you can sort of see there. Then you've got, this is the more efficient system where it's like, you can tell that it's like the top line, the middle line, the bottom line, the left, right never gets powered entirely, and then this is the more custom systems that get sent through. So like, this would be, so that's 0, 3, 2, so a unique thing that just 2 and, yeah, just 2 has, which if you want me to follow it, I will now. 2 has, yeah, 2 is the only one that just powers that, considering 2 is, yeah, how do you draw 2? Sorry, I'm just going to move around. Yeah, 2 is, 2 is that symbol. So that's why I needed that one powered as the middle and bottom, and then that should also be powered by the 2 signal. Maybe it separates off at some point. I can't bother tracking it at the moment. Which I know at least one of you really wants to know how multipliers work, so I'll be going into that now. Why are there so many creepers? So this is just the input of the code. It goes up to max. I was originally thinking going up to 8, and then I realized because of how it works, I could go all the way up to 15 with the multipliers, even though you really only got, I have a multiplier at the moment. Let's go 9 times 9. Maybe go 9 times 10, so it's 90. Let's just test this system is actually working. I probably don't need to come over here anymore to execute it, or did I not? Did I actually remove that? Oh, unless 2p at p. Well, unless I've turned off commands on this world, it seems that that was mainly just to teleport me around when my simulation distance was lower, because this thing is so big the simulation distance couldn't. It would teleport me to that, which would just allow me to load this chunk when plussing. It would teleport me to over here because of how simulation distance worked. I couldn't load all the way down here so it would teleport me into this tube, fall me down, then after that it would then teleport me all the way back up to here to view the output. It should be set to 90 at the moment. It is, yay! And since, yeah, that's how that works. So multipliers. Okay. If you're probably best to actually look up binary calculations yourself on how multiplying in binary works, but you kind of have to, how you multiply in binary is you multiply it across similar to how you do it in in the decimal system. You would, from how you do the first one, multiply the entire system, then the second one times shifted over by 1 times the entire system. So you sort of have that, but since it's ones and zeros, it's either 0 times the whole system, which is nothing gets through, or 1 times the entire system, which the signal gets through. So you will see that. Let's follow this one, which I believe is, yeah, the 1. So this would be from the yes, this would be from the 9 because of the bottom one. I don't actually, if I will be on a side note now, this, even because I don't actually have to use to destroy, to interrupt this line when I'm doing plussing, because if 0 times doesn't matter what will always be 0, so the output doesn't interfere with the other plussing system, which I find is quite useful. Yeah, there's a then yeah, so you can see that this is the 9, so you would have, so this is the top, was this bottom or top? What the hell? Iron 9 is, Iron 9 has a 1 at the start, so this is the first one. Yeah, I was getting lost. Yeah, 1's the 2-second decimal, the 3rd, the 4th. Yes, as you can see, that's why 9 has, at the 4th one it's powered, and then the first one it's also powered. You can tell there. So yes, most of these are just trying to figure out third. How did I do the third one? Oh, these systems are actually the removal. This is the, yeah, this is that system, that side of that system. So you can tell if it's 1, it will come up, use the invert, invert, invert. So then it allows the signal to get through. If it's 1, using, that's just using them. And since, so that's the first, that would be that time for the entire system. Then you can tell that the entire system has been shifted 1 up and across, up, and you can see that as you climb up the system. So from the first digits, which I think I've got it labelled here, yeah, first, or second probably for the top one, considering I times it by 10, which, yeah, 10, which would turn that to 0 and that to 1. Sorry for being complicated. Which then keeps following through. It does work in theory in survival, it's just damn difficult to build, by the way. This is all based off survival capable redstone. And you move up again because of how you move it. I moved it up and across so it's lined up so that every single thing in the lines will add up together when you're adding the system, when you're adding the, figuring out your final answer for your multiplication. If you look up how multiplication works in, best, as I said, the binary systems, it's just addition takes up a lot more room. That's why you'll see it kind of growing outwards after it. And it basically uses the addition system. This system was me, because I learned how addition worked first, this is sort of me cutting corners, figuring out ways of overriding the systems. This, I think, I was just getting it because it was the first one of trying to just get it away. Okay, so this one, but then you'll see after that it actually works off actual addition, which you'll just, if you actually follow the systems, there should be 3. Yeah, you'll see that there's, you got the original one from the first one. If it failed, if it overflowed to the next one, you have to see the 1, 2, 3 input. Then you can see that the, because I use command block, that's why it's a bit inefficient like that. Then you can see that that's the equivalent of the overflow. Oh, that's the 1, that's the, so that decreases, I probably should have mentioned it decreases 3 signals to 2 signals. Then you can run the first, that output to either a simple addition system, which is based off the third one. And then, because each one of them can have an overflow, both of those could activate. There is ways of, if you really think about, write out binary calculations in your, on paper, you'll see what I mean. You have 2 overflows, so plus 2 essentially, so that's why both of them go in. And you're kind of basing off the same system here, where you have 2 from the original, 1 from the previous, and that goes up. Then you got 1 from the previous, 2 from this one, or is it, yeah, 2 from this one? Or is it, oh yeah, you got the, not 2, it's 1 from the follow through, 1 from this, and then 1 from the original, then 1 from the non-original, the overflow from the previous, so 1 from the original, that from below, and then that, and then that just happens one more time, or based off the basic one that I've kind of developed, which basically works off of similar principles with maximum combinations. I did try to do it with the actual combinations going through, but it just got too complicated at one point that I sort of gave up. Just using this compounding addition, you don't add, so you sort of follow it through, and that's basically it. You don't actually need to have the original addition, which is below this, separate from the multiplication addition. You could technically run it in such a way that you'd use this as the system, but I built this system first because I didn't know what I was doing. Literally, this was how I learned. You can still see the command blocks from when I cloned its system across. That goes into here, that then just interacts my binaries. So this is the 3rd digit, which then goes down, 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 down into this system. Based off, I built it in an order this was easy to build, but just had to fly in here. Sorry for the nasally voice. Yeah, and you can tell that the system is it. I tried to compact it a bit more, but this is basically as compact as I could get. Why couldn't I get it closer together? I don't know. I would have had a reason. I'm not that type of person who wouldn't do things like this for a reason. Maybe I built something and then didn't realize it or something. Maybe I didn't know how this. Maybe it was because I didn't know how this was gonna work originally. So I built it like this to give me plenty of room, maybe. But you could maybe compact that. I don't really know. And since we've already been through here, which is just, this is the ones, which every single thing will go up, and the 10s, and that sort of converts it running through a bunch of this is probably a thing that you wouldn't try to learn. You just hard code this. You just learn it as you go. I don't recommend using whatever technique I've used for the 10s. I do recommend the convert it into tops, using the same trick that we used before to when you don't want it signaled and when you do want it to be signaled. Of course, since from above you don't actually power repeaters, which you'll be, I don't think that this is actually on the end, so you don't actually, there's 0, you don't actually notice it because I just didn't bother putting redstone there. You can tell till it became applicable. And you can see that 1 I didn't do because just the left was enough. Oh no, top. I must have done something strange with the 1. Must have done something unusual. Because 1 does... Oh no, left. Left is that one. Okay. I know 1 has to work, so I just don't know why it works. I will just have to go check that. It's multiplier, we can work with that. And 1 times 1, really? Would work. Then just the signals, just 1 goes out. Now, you can tell this is probably the simplest calculation you can do. Okay, 1. So 1 goes through here. Oh, this is where I put the left. Now I remember. Yeah, this would be left. No, no left. No, right. That's right. Whoops. Yeah, left. Yeah, you do have left systems for 8, primarily, I think it was. Maybe a few more had left fully powered, I don't really know. And then you see that sometimes the repeater will end, that's on purpose. Well, that was stupid of me, and then, yeah, the repeaters are, this is the right one, which is also equal to 1. That would be, well, I can't put that down there, but you get the idea of what it's trying to do. And yeah, hopefully that helps anyone who wants to build a calculator in. If you want a minusing and division machine, it'll be hard, but if I get support for this, I will actually produce one of them. And yeah, don't forget to subscribe, but considering I'm a small YouTuber, doesn't really matter much, shouldn't really matter my increase in people following me much, but yeah, hopefully that is enough. Any questions, leave it in the comments. Again, small YouTuber, can actually read every single comment. And don't know what just activated, but yes.